Alright, here's a video on how to replace the elements on a electric water heater. I'm going to move around here, and I've got this voltage tester, and this is the top element, and there's a bottom one on this tank. As you can see, there's power coming in. And there's a way to test these elements if you unhook the wires and you use an ohm meter. I've replaced enough of these that I'm pretty sure that's what it is. So the first thing you've got to do is turn off your power, and then you'll hook up a little garden hose to this, and over on the floor there's a drain, and we'll just drain the water out. That's what you want to do to your tank first. Okay, so when I go to test these, now that I've pulled the fuse box in this house, you can see there's no power coming to any of these. You're going to want to turn off the water supply that comes into the top of your water heater, and then once you hook up your hose and open that valve, you just crank this one left to open it up. Once you do that, you want to release this lever at the top so that there's not a vacuum holding up your water flow from the bottom. That's your pressure release valve on the top. It depends on the water heater, but it might take a half an hour or so to drain it all. Once it's drained, what I want to do is just run over to the hardware store and pick up two of these elements. These have a piece of metal that goes into the water heater a good distance. You want to make sure you get the right amperage or voltage when replacing those. Okay, so I went and bought a new element, and I just wanted to show you what it looked like on an ohm meter. If you connect the two leads on this ohm meter, you'll see that it's reading about 13.1, 13.2. Now I'll show you what it looks like on a bad element. Usually it's the bottom element here. I already tested the top one, and all you have to do is disconnect the wires and just put your leads from your multimeter onto the screw heads. Alright, so this is the bottom element. Still have a little bit of water draining out the bottom, but go ahead and test this, and you'll see that it looks like I'm getting about, well, it's reading weird, which could be just because the element's cracked, but it's definitely not that 13 ohms reading. So this is probably the elements that's bad. I'll go ahead and pull this one out and show you what it looks like. To pull it out, you just need this tool right here. It's called an element wrench. You just put it on the element, put a screwdriver or something there to give you some leverage, and twist it out. Kind of like a spark plug. Okay, so I just pulled out the top element, and this is pretty typical. You'll see some hard water on there. We have a lot of hard water in this area. And this one's actually still intact, so that one's good. We could reuse it, but the elements are only about 10 bucks each, so I just replace it every time. So down here I've put the new element in, and that's just how the wrench fits on. Now this is pretty important that when you use this wrench, you want it tight enough that it doesn't drip down here underneath it, but not so tight that you break it. These can be a little bit fragile, and so you don't want to screw up the threads or break any part of the element. Okay, so I just pulled out the bottom element, and it actually looks not too bad, but except when you get right down here to the base, you can see that it popped open. And so anytime there's going to be damage like this, you're going to have basically a short there, and it's not going to really let you get hot water. If you look closely right there on the side, you can see the specks of it, but also on your water heater you should have a label that tells you what the voltage is and the wattage for your elements are. Okay, both the elements are in now. First thing you want to do is turn the water back on. I don't turn the power on until I make sure there's no leaks. It's very important you leave this pressure release valve open so that as the water goes into the tank and fills it up, air can escape. So this is what it kind of sounds like when you turn it the right way anyway. So you can hear the water going in there. If you keep this valve closed for a little bit of time, then pressure will actually build up in that tank. And you can kind of hear that pressure release there. Took about a half an hour to empty this tank. It shouldn't take very long at all to fill it back up. What I do while it's filling up is check under each element for any water dripping, both the bottom and the top. Make sure you dry out the little tray that's underneath it to better look and see if it's leaking water. These types of tanks will last for a really long time if you just make sure that any leaks get taken care of so they don't rust out. And all you have to do is replace the elements every once in a while. Okay, you can tell it's getting close to filling up. And actually that was it. So you'll be able to hear in the tank when the air is getting less and less in there. And once it's completely full, you'll want to close this quick release valve, because otherwise water goes down that pipe and onto the floor. You can always test this out every once in a while on your water heater. If you just open it real quick, you'll hear kind of a pop of air, but then you'll also hear water coming out of that pipe, which isn't a huge deal. So the tank is completely full of water. One thing I forgot to mention is you never want to turn the power on when you have an empty tank. These elements will just blow up if there's not water around them. I bought a rental house a couple years back, and my agent actually went in there and turned the water heater on so that we could see if it worked, and she heard a big pop. And that's exactly what happened. So never put power to a water heater unless you have water in it for these electric ones. We'll hook it back up and then get the power going and see if we got it fixed. Alright, one more thing on that water heater fix. As I was talking you through the element replacement, you probably noticed something that looked like this, which is the upper thermostat, and this is the lower thermostat, and that's what controls the two elements. And when I first pushed the fuse back in to the fuse box, you couldn't hear the water heater working. So I was running to the store to pick this kit up. It's actually cheapest just to get it all in this kit. And I was going to replace both of these parts because every once in a while those go out. Not very often though. But I had a thought as I was coming back to the house that maybe it was the fuse box. And these are bus fuses that are meant for a 250 volt current there. And they sit side by side in the fuse box for that particular circuit to the water heater. And so I actually pulled both of them out and tested them. And this is another thing you can use your multimeter for, is to test fuses. Again, you're going to put it on the ohm meter. And this particular fuse is a good fuse. If I can get a good reading on it. And so clearly there's some type of movement on on this fuse, and this was one of the fuses that was actually in the box, in the fuse box, and one of them had an ohm reading, and this one completely dead. Even if I move the leads around a little bit, there's no activity whatsoever on that, and so that fuse is completely dead, and that's how you can kind of test for those. So make sure before you start replacing everything, you know, a lot of people have the circuit breakers, so that makes it easy, but even circuit breakers can go out too. So you want to make sure that you're testing all your electrical equipment to isolate what parts you actually need to replace. Everything's good to go there now. We got hot water.